Hello and welcome to TechTakshila System Design Mock Interview Playlist.
Hello, and this is our new segment where we plan to show you guys that what goes on in an actual system design interview. So let's get started without any further ado.
Hi Bob, nice to meet you. I'm Alice.
Hey Alice, nice meeting you as well.
So we have this time reserved for your system design interview. In this round, we will gauge your design skills and your expertise with working on large-scale distributed systems. So are you ready?
All right, sounds good. Yeah, I think I'm ready.
All right. So I hope that you use some social media platform like Instagram or Facebook or maybe Twitter.
Mm-hmm. Yeah, I do.
Okay. So you might have seen that whenever your friends post something or share some links, it shows up on your wall. We call this a timeline.
Yeah. I have noticed it.
All right. So the question for you is that you need to design a newsfeed feature where newsfeed gets posted or shown on your timeline. So how would you go about it?
All right, so let me just quickly write the question down so that we are on the same lines. So you said that design a news feed feature or service where newsfeed gets posted or shown on other users' timeline. Is that what you said, or am I missing something?
Yes, that's correct.
Cool, yeah, okay, great. Yeah, I think what we can do is like we can go and like take an microservice architecture approach here for this service build up. So that's the one way that I'm gonna like approach this problem.
Okay, that's great. But I think we should first get over the requirements for this new service.
Ah, I see. Yeah, sounds good. So you mean like what sort of features or like user experience we want to provide to the users?
Yes, that's correct.
Got it. So let's start with the basic requirements here. So the first users should be able to post their like new post or like post something onto the social media platform. So users should be able to post new stuff. Let's just say that. Next, we can also make the post to be like a text-based post or some sort of media where like audio or video we can share. So it can be like different type of content that we are sharing as post, and we can also like share some third-party content, which is like some URL from like external resources where like
hmm
CNN, CNBC news articles can be shared on our platform as well by different users.
Makes sense. So that's a great start. What else do you think?
Yeah, I think next would be that these posts would be shown to users, friends, or followers in case of like Instagram like platform. So let's attach some of the nouns to these objects. So a user who posts something would be called as poster. So
hmm
user posting is a poster, and then we can have another user that basically sees this content will be a follower. So
hmm
following user will be called as follower, and then the content that we are showing to the user will be called post. Okay, so
hmm
content will be called as post. And
Okay, that looks great.
mhm.
What else?
So I think we are like sort of done with like the functional requirements. So we can now try to gauge some of the non-functional or like infrastructure related requirements, like which region
hmm
this feature will be launched, or how much traffic are we expecting per region for capacity planning, if there are any special requirements to handle like a surge in the traffic.
hmm That are all good discussion points. Well, for ease of use, let's assume that we are only launching service in North America for phase zero, and we can expect 1,000 TPS as rough average traffic.
Okay, so it's 1,000 TPS, and we are only launching in North America, right?
Mm-hmm. Yep.
Great. So that sounds good. But what about like followers or posters?
What about them?
like for example, poster can be a celebrity and might have like more than 100,000 or even more than 1 million followers. So that can put like extra stress on the service.
Mm-hmm. Yep, that's a good point. Let's consider that as well for the P0.
Okay, so we will design this service to work differently when a celebrity posts something, but differently when posters are normal users with less than like 1,000 or 100,000 followers.
Okay.
There could be like other added features that we can bundle with this service.
Okay. Can you provide some examples?
Sure, like so for example, that like if users can also react on some of these posts by liking, commenting, or sharing the post.
Mm-hmm. Yep, really good point. But let's not focus on that for now. Let's keep that as an extended requirement. I would say we can circle back on this if time allows.
Okay, yeah, that sounds great. So I'll now show or like start with how the posts are stored in the NoSQL databases. And
Well, I would say that's a giant leap. Let's start one by one. Can you draw a high-level component diagram for me before we decide that what sort of database is better suited for us?
oh, okay, got it. So sorry for jumping the guns here. You are right. I should focus more on the high level conceptual diagram before like jumping into all these nitty-gritty details of like databases.
Cool, thanks.
All right, so let's first start with the customer itself, the user. So, okay, so we are starting with the user first. So in this first scenario, we will first start taking the case of storing the post in the database.
Mm-hmm. But given the short interview duration, let's say that the posts are already in the database. We only want to fetch them to show it to our followers.
Okay, got it. So here's our follower. Let's say in this case, this is our client who first calls the Instagram's API to fetch the post from the other posters.
Okay.
Okay, so once like this Bob will like let's call this user as Bob, and so currently this user is basically sending this HTTP request to our front end database front end service, which is just a
Mm-hmm.
load balancer.
Okay.
And once this request lands onto this load balancer will basically help us to gate the internet traffic here.
Mm-hmm.
So after this load balancer, which will perform like some sort of basic validation on the incoming packets, it will forward this upload request to the newsfeed service. So
Makes sense.
we will have our newsfeed service here. And once this newsfeed service will like check what type of request is this, since this is post read request, this newsfeed service will act as like a central controller to talk to all the backend services or data stores to return the newsfeed back to the client.
Mm-hmm. Yep, sounds good. You're going in the right direction.
Cool, thank you so much. So first, this newsfeed service will go query this newsfeed database and fetch all the news feeds for that querying user.
Well, quick question for you. What sort of database are you planning to use here?
Yeah, so I think that's a good question here. So I was about to explain that. So basically, we will be using a NoSQL based database in this case.
Okay. And why NoSQL and why not relational?
So as we have like mentioned in the requirement section as well, that we want to regionalize this newsfeed service down the line. So that would basically help us to partition this NoSQL database easily. And also like we can create many partitions based on the user IDs to horizontally scale our databases. So that would be like a couple of top reasons that I can think of to make the choice for NoSQL databases. And secondly, since we are like expecting huge amount of traffic down the line, it will be easier in that case also to basically use cheap commodity hardware and not think too much about like how the relational databases in the alternative approach would be like.
Makes sense. Makes sense. So yeah, let's continue with the component diagram.
Okay, cool. So basically now what we will do is that once we have like this newsfeed database returns all the list of post IDs, we will query those post database to fetch the actual content for the post.
Well, hold up. Can you quickly tell that how these newsfeed database had the newsfeeds in the first place?
Oh, okay. My bad. Like I think I missed it in the first place, but I thought like you mentioned that this was already given to us.
No worries. Can you elaborate it a little?
Yeah, got it. So when the poster posts something, we will start a job in the background where like the job queries will just basically query this like a new followers database, which I haven't like created, but like let me just complete that picture. So we have this follower service, and then we have this follower database. So basically we will have like a follower database reader job, background job, which basically reads from all these followers. And once we have like fetched all the followers for all the users that are like following for that poster, we will basically create one row in the newsfeed database for that particular user to show the feeds for that particular user that he has been following till now.
Mm-hmm. Mm-hmm. But why a background job? Why can't this operation be online?
That's a really good question. So the main problem we are trying to solve is like excessive read load that can come to this newsfeed service. So for example, whenever a user tries to fetch posts for his or her news feeds, they would be calling like this follower DB and the post DB all the time. So it would be easier for us to basically pre-compute all these results in a separate database like this newsfeed database in the first place.
Makes sense. What a nice idea. But what about the space?
Hmm. I see what where you are getting at. By space, you mean that if the poster is a celebrity, then what will happen?
Exactly. So what will happen if the user is a celebrity?
Yeah, I see. So I think as we have discussed in the requirements section that we need to treat this use case a little bit differently. So we will take the online approach in case of a celebrity poster where we will not pre-compute the results in this newsfeed database, but for a case where like the user is basically a normal user, we will basically fetch all the followers from this follower database and put their users newsfeed in this NoSQL database for the newsfeed.
Okay. But would that add latency as you were telling earlier for which you pre-computed the results in the first place?
Yeah, I agree that it would add like some latency, but that would not be too much. And we can further reduce it by caching the results back into a newsfeed database, as we have done like in the first place by pre-computing. So we will also like sort of accentuate our existing field in the database.
Mm-hmm. How would you do that?
Yeah, so let's say that we have some XYZ user that opens up the app first time today. So we will start fresh with querying followers database and then querying the post database to fetch all the posts for all the celebrities in today's date. But once we have did that, we will just basically store all these posts in the newsfeed database again
Mm-hmm.
with like other news feeds that were like already pre-computed for this user. Yeah, so then let's say that XYZ user comes in 1 hour and we only need to query the post database in that 1 hour instead of the entire day, since all the posts prior to the last 1 hour were already present in the cached database.
Mm-hmm.
So that way we will not be wasting any space by aggressively pre-computing the results for all the users that were followed by that were following the celebrity, and at the same time reducing the latency of calling the database again and again, and then putting more pressure onto the post and followers database consequently.
Okay. Yeah, I think that looks to be a better approach. Well, you can finish the rest of the design now.
Yeah, so once this list is like kind of returned back to the newsfeed service from the newsfeed database, we will call the post database to actually get the content specific details like title of the post, is it a photo or video content. So we will do that afterwards, and this is the post database in our picture. And in case of like photo or video, we might need to call like a separate object data store like Amazon S3 or Azure Blob Store, since the size of the object to show can also vary in that case. So we will do that through our layer where like we have load balancer or some sort of cloud front that we are like attaching to our service. So I'll just write AWS S3 for actual content.
I see. Can you draw the schema for these tables that you're using?
Yeah, I think that's a really good question. So I have like created a rough diagram beforehand, so we can go over that. So basically, as you can see, this is pretty much related to what I have in the first place, and these are the three databases. So the schema for all these databases is like, let's first start with the newsfeed. It's basically, we will like primary key on the user ID so that we can partition it later on, and then we will like have a post as like a separate field which will store all these list of posts that we need to show as a feed to a user. And then we will like also store some sort of metadata that when was this post was created, and some sort of like user last activity time, so that we can do some analytics later down the line. Other than that, we will have like post and followers database. So followers database is basically a mapping between like what users are following a particular user, and if the followed user is a celebrity or not, since we want to like treat those cases differently. So let's say that we have XYZ user that is following Bill Gates, so it will be basically a celebrity user, and then it basically has like that sort of demarcation that if you want to pre-compute the results for that particular user or not. So that's what hinges on this design. And in the end, we have like the post database that actually stores the detail about the post. So we will have post ID as our primary key, and then we will have like who posted that, so the post owner ID, and we will also have like the timestamp, the media URL, and the post text. Like if in case it's a post which is just text based, like a status or something, so we will store that in the database instead of like storing that in a separate object data store, because like that's pretty counted. We, as we know, like we'll only do like 70 or 160 character based text based post.
Makes sense. Well, that looks good. Also, can you draw the API request response model between these services as they are interacting with each other?
Yeah, I think that's a good question. So I also have like done some rough drawing for that as well. So let's see that here. So this is the kind of API request that the users will be sending. So this will be a GET request to read all the feed, and this will be injected with the user's ID. And if you look at the diagram, the user will be sending this as the HTTP API request to this load balancer that will further get down to the newsfeed database, newsfeed service. So once we have like this request being received by the newsfeed service, then basically newsfeed service will return this sort of response back to the load balancer and back to the user, where like we have this JSON object which has like all the feeds in it, and they are like a array of all the posts that will be shown to the end user. So here we have like a post ID, the post owner's ID, the post owner's name. So that's some sort of like metadata that we'll be sending for like showing the preview of that particular post, and then the media URL. We can also like add other fields as we go along, like title or like some text that we want to show with the post, or even like some sort of preview for like third-party URL. So it's pretty extensible based on like how the front end wants to get the information.
Okay, that's perfect, and it looks good.
Thank you.
Well, we are towards the end of the interview. Would you like to suggest any improvements and enhancements in your design?
Yeah, so as I briefly mentioned, that there could be a latency impact while we were like bringing the what post we want to show to the end user.
Yes.
So we can place a Redis based cache cluster between the newsfeed service and the newsfeed database.
Okay. Can you elaborate more on this, please?
Yeah, so I have a rough diagram here with me. So what we would like to do is like we would be, as you can see that since we are seeing this like newsfeed database can be called a lot by daily active users, it would be best to cache the post for them in this newsfeed service cache cluster, since calls to the cache are cheap, and also if we miss showing some new post if to the user, it would not be the end of the world. And we can also implement this Redis based cache as like write back cache, which means that whenever an update is made in the background to the user's newsfeed database, we would basically update the cache also with the updated copy of the newsfeeds. And then we can query this cache whenever a user wants to see their post, given that user is seeing the latest copy of the cache available.
Okay, well, that sounds good. Well, that's all the questions I had. Thank you so much for your time, Bob.
Yeah, thanks for the opportunity. Looking forward to hearing back from you guys.
So friends, this was the basic system design mock interview.
And we'll be creating more such content. So feel free to provide any inputs in the comment box down below.
Also, please subscribe and press that bell icon for receiving updates on our latest content or more of such mock interview videos. Thanks, and we will see you soon.